The types of problems that you'll encounter during your exams will not be as simple as the ones that we saw previously. You're going to be experiencing data loss inside of those in your questions. Over here, we're going to be using a tool which is used to create sequence diagrams. You're going to be using this tool during your exams as well, so that you don't have to draw the diagrams that we did previously. Okay, this gives us the ability to create sequence diagrams to send messages between two entities, A and B in this case. And the syntax is very straightforward. If you want to do an arrow, you just label your entity, and it's a dash and an arrow symbol. If you want to change the direction of that arrow, you only need to change the direction of that, and then instead of A sending to B, it's B sending to A. This one's probably better. Very first one. Yeah. Okay. So you can see that the direction changed. Okay. There's a full documentation. There's a full documentation page underneath the help section that goes through the syntax, but it's very simple to use this once you learn how to make the first and second arrows. The only three types of segments that we'll need are A to B, which is just this caret symbol, lost packets, which is this X dash, and notes, okay, which is note over, and then if you want a note over only A, then it's note over A. If you want over B, with note over B. If you want both of them, there's a comma in between it. Okay, so that's pretty much all you really need to know syntax-wise for this tool. And most likely I'll give you a question like this, and then I'll ask you to use the sequence diagramming website, and then you can just copy this code into Blackboard, and I can create it from there. Okay, so in this question it says A initiates a TCP connection with B. Once the connection is established, B sends 3 segments to A. Assume A's window size allows acceptance for these. These segments are of length 100, 200, 300. So it's the same so far as the previous example. Segment 2, 200B, 200 bytes is dropped. Okay, so when I'm sending these 3 segments, 100, 200, 300, the second segment, this one, gets dropped. Once A has all 3 segments, it will send 3 segments to B. Okay, so it's sort of a response. Assume B's window size again allows the acceptance of this. The segments are of length 300, 200, 100 in that order. The data segments are received. Okay, so we receive all these 3 data segments, but acknowledgements for segments 2 and 3 are dropped. Okay, so when we send a data message, we get an acknowledgement that corresponds to that data message. In this case, the acknowledgements for 2 and 3 are dropped. And what happens in that scenario? How do we recover from that? Okay, so we'll walk through the process of how TCP recovers. You did have a few notes on the lecture about how to do this, but it's much better to just see how it gets recovered than to go through a step-by-step algorithm. Okay, so first we have our three-way handshake, which I've put here already just to fill it up with some initial data that sets our connection established. And then when we're sending data, okay, so when we're sending messages, typically, well, almost what I expect from students to give me for answers would be to label the segments. In this case, I labeled it a data segment. And for data segments, you should have sequence number, acknowledgement number, and the length of the data. And then if it's an acknowledgement segment, then you should have the sequence number and the acknowledgement number that's being transmitted. So in this first segment, so you can use it. This one doesn't allow for overlapping lines. So you can, or at least not in the short documentation that I've studied. So you can either use the Same notation where I did, where I had 3 segments sending and then 3 acknowledgements received, or you can have data acknowledgement pairs. Either one is fine. So in fact, for this first question, I'll do it the same way as the previous example. And then for the problem 3, I'll switch it around to do data acknowledgement, so on. But the order doesn't really matter. Okay, so this one maps more like the real world, because after a connection is established, when we start sending data, we essentially send as much data as we can right away. Okay, so we don't need to wait for an acknowledgement to continue sending data. So this maps more like what we would expect. Okay, so in this case, B sends 3 segments to A. So in fact, I need to change the direction of this. B sends 3 segments to A, and the segments are of length 100, 200, and 300. Okay, so the sequence number, okay, is 1. The acknowledgement number for the first packet is 1 because I haven't received any data, and the data packet is 100. The sequence number for the second one is going to be the data plus the sequence number, so that's 101. The acknowledgement is going to be 1 because I haven't received any data yet, and the second segment is 200. And then the third one is 200 plus 101, that will be 301. And the acknowledgement is 1, and the data is 300. Okay, but the instructions over here says that this packet was dropped. Okay, so the second packet was dropped. So we need to see how the system responds to this lost packets. Okay. So now we are sending back acknowledgements. So this acknowledgement is for this one. So you can sort of think about a line over here that's darting under over here. So, right, you can think about a line directly underneath of here that's darting to this. So this is an acknowledgement packet, so it's only going to have sequence acknowledgements numbers. And the sequence of this is 1. Okay, and this is acknowledging that I've received the first segment. So the next sequence number that I'm expecting is 101. Okay. And then when I miss this one doesn't get responded to because it's not received. When I receive this one, the system is expecting sequence number 101, but it receives sequence number 301, so it knows that there was data loss. There was a packet that's either delayed or lost. So it's going to respond back with acknowledgement of the segment that it's missing. So it's saying that I'm missing this segment over here. Okay, sequence 1, acknowledgement 101. And then B recognizes something called a duplicate ACK. If I see a duplicate ACK, an ACK that appears twice, then in that scenario, I will start transmitting everything after the segments. So even though A has a copy of 301 to 300, we don't know that A has that packet. Okay, we don't know whether it was only packet 2 that was lost, or whether packet 2, 3, etc., everything subsequent was lost. Okay, so B in this scenario, when it sees the second duplicate ACK, it will retransmit everything, everything that was not acknowledged. So in this case, it won't send back this segment because it has acknowledgement 101. So acknowledgement 101 is saying that everything prior to 101 was received. So this segment was received. So it's going to retransmit these two. Okay, and then this time we're going to assume that the data was correctly received. Okay, so once it's over here, again, we need acknowledgements. Okay, so don't stop just like at this point. You need acknowledgements. And the acknowledgements are not going to be what you expect. Okay, so you might think that the acknowledgement for this one would be 200 but plus 101. But that is not the case because we store our missing packets. So This one we receive, and then this one, when we receive it, we send back the duplicate ACK, but we keep it in memory. We don't discard this because this is going to allow us to sort of jump fast forward in time. So as soon as we get the missing segments, then we essentially can tell the other side that we've received up to 601. Okay. So we can tell the other side that we've received up to 601 because we've received, let's call this segment 1, segment 3, and then as soon as we receive segment 2, as soon as we receive segment 2, we can send back this message. So in fact, this one might have not even been appeared yet, but this one will get coming. This will come. And then when this one arrives, we need to acknowledge this one as well. We will send again sequence number 1 and 601. Okay. So you can see that when we receive this one, because it sort of completes this collection of 3, we can jump our sequence number ahead. Okay, and this makes sense because if we had, let's say, if we use 301 over here, this is only telling B. This is telling B that I want you to send me this segment. I want you to send me the segment with the last 300 bytes, which is not what I want because I already have that segment. A already has that segment, so it does not need that segment. So it's going to acknowledge instead 601. Okay, so right. So if it looks like this, it's going to send back 601. Okay, and then we can have these two again are pretty much transmitted together, but this one looks a bit. This one illustrates that it gets 601 back immediately. And then this data segment, because it's a duplicate of this one, it's just discarded. And then we have the second half. Once A receives all 3 segments, it will send 3 segments to B. Okay, so now A is going to send 3 segments to B. A is going to send 3 segments to B. In fact, we'll add a note over here. A sending to B. Okay, we can add a note over here just to section off what we had previously. And in this case, I'll do the data ACK notation. So in fact, let's clear out all these old values. Okay. So A is now sending to B. A's sequence number is 1. Its acknowledgement number is 601. Okay, that's the last message that acknowledged from B. And its data, in this case, is 300. The second segment would be data plus sequence number, 301. The acknowledgement number would be 601. Again, this is from the previous message. And its data would be 200. And then finally, we have sequence number 200 plus 301, which is 501. Acknowledgement again is 601, and data is 100. Okay, so these three get sent out, and I'm going to get acknowledgements for each of them. Okay, so the acknowledgements for each of these should be, okay, I'm just saying should, I know some of them are going to get dropped, but we'll take care of the dropping afterwards. Okay, so these are coming from B to A. And from B to A, let's see. From B to A, my sequence number is 601. Okay, so I've got, this is a bit messy. Maybe I should flip these arrows around, but this was the last segment from B to A. Okay, and you can see it's sequence number 301 and it's 300 bytes of data. So the next sequence number should be 601 from B to A. And the acknowledgement number is acknowledging the receipt of this data. So it should be 301. Okay. And then over here, again, our sequence number is 601 because we haven't received any data. And we're now acknowledging the receipt of this additional 200 plus the previous sequence number is 501. And then the last one, receipt of last 100 bytes plus 501 is 601. Okay, so this is what we should have. But again, we have data loss. Okay, so in this case, acknowledgement for segments 2 and 3 are dropped. So here is acknowledgement 2, so this one gets dropped. And this one gets dropped as well. Okay. So in this case, B has received all the data. Okay. But A does not know that it's received all the data because all it knows is it received this first ACK back. It did not receive these two acknowledgements back. So what's going to happen is after some time frame, this is called the retransmission timeout, it's going to time out. The sender is going to time out. Typically this timeout is, I believe, 1 second at least, and at most 1 minute. So this is going to time out eventually. And then when it does time out, it's going to start retransmitting all the segments up to its window size up until the segment. So it's going to start transmitting from the last segment that was acknowledged. So the last segment that was acknowledged in this case is, let's see, this one is sequence number 601, acknowledgement 301. So it's going to retransmit after this. So it's going to retransmit this segment. Okay, so acknowledgement 301. So it's going to start from sequence number 301 because this is the next expected sequence number that A understands. And it's going to send both this segment and the other segments. Okay. And then we're going to get acknowledgements back for each of these. Okay, so, and the acknowledgement in this case, as soon for the first one, is it's going to receive this 200 sequence number 301 and acknowledgement 601, and in fact, we'll do alternating. It's better. It's going to see the sequence numbers 301, 601, and 200 bytes of data. And the sequence number that it's expecting at this point is 601. Okay, so it's going to throw away this piece of data because this is data that it already has. It has it from here. Okay, remember none of our original data segments were lost. It only lost the acknowledgements. So it's going to send back going to send back acknowledgement saying, give me the packet after 601. And this is going to be the exact same. Okay, so when it receives 501 to 601, it's going to say, that's not what I want. I want 601. I want data starting from 601. Okay, and at that point, we can begin the closing handshake once all of that has been received. Okay, so we'll look at the next example, which is very similar to this. There's just some slight variations about how TCP deals with loss, and these 4 examples cover pretty much most of the use cases. Okay, so in this case, A initiates a connection with B, which we have, A to B. Let me change this to B arrow A, which is slightly nicer syntax. And the same over here, B arrow A. Okay, so in this case, A initiates a connection with B. Once the connection is established, B sends 3 segments, again 100, 200, 300. This time segments 2 and 3 are dropped. Okay, segments 2 and 3 are dropped. It's not just segment 2 from before. This time we lose 2 and 3. So in fact, I can just copy this one over, because it should be the same, except that this one turns into an X. Am I missing something? Right, I should just get rid of this. Okay, so sequence 1, acknowledgement 1, sequence 101, because it's data plus sequence number. Acknowledgement is still 1 because I haven't received any data from A. Data is 200, sequence 301, again 200 plus 101 to get 301, acknowledgement of 1, data is 3. But both of these segments get lost. Okay, so in this case, A receives the first segment, okay, and it's going to send an acknowledgement back for this first segment. Okay, B to A. B to A, it's going to say acknowledgement back to A. Right, so this one is, should be, I see what I messed up. I want this one to be here. A initiated, B sends 3 segments to, no, this is right. B to A. And this should be A to B. There you go. Okay, so A is sending an acknowledgement to B. And the sequence number is going to be 1. And this is acknowledging receipt of the first 100 bytes. So this should be 101. This is the segment that I'm expecting next. Okay, now what's going to happen is, in this scenario, because B doesn't have anything else to send at this point, it's still waiting for the acknowledgements for these 2 segments. Okay, and in our previous example, we were able to detect that data was lost because of this double ACK. Okay, this double ACK allows us to immediately know that something bad occurred, that some data was lost, because this segment sent us back saying that, hey, something's out of order. But if we don't get this one, if we lose this one also, then it never gets that never gets that heads up that some data was lost. So this one can't tell us that data was lost because this one was received correctly. Okay, so you can sort of think that like this one's occurring right here conceptually. Data sent, data received, and then these 2 were lost. Because these 2 were lost, you're not going to get any acknowledgements. that something was lost. If you had another segment that was going to come, okay, if you had another segment that was going to come down here, okay, these numbers are all wrong, but if you had another segment over here, then this one will allow you to get an ACK back that will be this one. This one will generate an ACK that looks like this. Okay, let's say that, hey, this was the last one that I received. You need to send everything starting from here. Okay, but I don't have it. I don't have this. So instead, what's going to happen is B is going to time out eventually. After 1 second or so, B is going to time out, and it's going to start retransmitting from the last acknowledgement number. So this was the last acknowledgement received. It's going to start retransmitting from here. So it's going to retransmit these two. Okay, so these two are retransmitted. And then from there, it's the same as, in fact, let's just do it. Okay, so acknowledgement number. So this first one is acknowledging the receipt of this segment. So this will be acknowledgement of 200 plus 101. Whoops, this should be, in fact, should still be 1. This is 104, 301. Okay, so this should be 301. Acknowledging the receipt of data packet starting from 101 of length 200. And then this one should be acknowledging the receipt of packet 301 with length 300, so 601. Okay, so next, once A has received all 3 segments, okay, so in fact we can add a note. B sending to A sending to B. Okay, so once A has received all 3 segments, it will send 3 segments to B. Assume B's window size allows for this. The segments are of length 300, 200, and 100. Okay, so again, we're sending 3 segments. And let me clear out this data. In fact, this should be, okay, so 300, 200, and 100. The segments are received, but acknowledgements for segments 1 and 2 are dropped. Okay, so let's see, A to B. So the last segment from, this is from A to B. These might be backwards. Okay, so we are sending from A to B. Okay, so the last time I sent from A to B, my sequence number is 1, my acknowledgement number is 601. So I'm going to be starting from here, effectively. My sequence number is going to be 1. This is going to be the first segment from A to B. And from B, I've already received 601 bytes. Okay, so I'm sending 300 bytes. The next one will be sequence number 1 plus data 300 bytes, 301. Acknowledgement number is still 601. And sequence number is 200 plus 301, 501. This is still 601, and data is 100. Okay, so now is the interesting part. We lose acknowledgements for segments 1 and 2. Okay, so the acknowledgements for this are B to A, acknowledgement of sequence number. So sequence number is going to be 601. Okay, remember this is from B to A. So in fact, this is the last one from B to A. Let's match our syntax over here, B to A. Okay. And so this was 301 plus 300, so that's 601. That's why we have sequence number 601 over here. This one is acknowledging, so this first one corresponds to this segment over here. So in fact, I can alternate it to make it matching that. Okay, so this matches this. So we're acknowledging receipt of the first 300 bytes. This will be 301. Then we have our second acknowledgement, which are acknowledging the next 200 bytes. This should be 501. And then we have the acknowledgement of the last 100 bytes. So this will be 601. And what we have over here is the first and second packet segments are lost. Okay, and this one is the most interesting example. Okay, so this acknowledgement is lost, and this acknowledgement is lost. So in fact, B has received all 3 segments. It was able to receive the data correctly. So it receives 300 bytes, 200 bytes, and 100 bytes. Okay. The only difference is A doesn't know that it received the first 2 segments because these were lost. Okay, but it does receive the very last acknowledgement, and this is actually enough. There is no retransmission necessary at this point, because what this last acknowledgement says is that B has received all 600 bytes, has received bytes 1 to 600 in the correct order. Okay, and that's just because if anything was received out of order, all of it gets retransmitted. Okay, but in this case, if the acknowledgements get lost, that is fine as long as I receive the very last acknowledgement. As long as I receive the very last acknowledgement, I can lose every single other acknowledgement. Doesn't matter. As long as I don't lose the very last acknowledgement, which is what happened in the previous example. In the previous example, I lost this last acknowledgement. Okay, so I lost both of them. I lost the second and the third one. But in fact, if I didn't lose this last one, I would be fine also. This because receiving this implies that I've received this first segment, this second segment, and this third segment. Because if I didn't receive any of these, let's say I didn't receive this one, okay, then when I receive this segment, the sequence number, the acknowledgement number that I send back is not going to be 601. It's going to be sequence number. It's going to be acknowledging sequence number 1 because I need the very first packets. So the fact that I receive acknowledgement 601 tells A that everything up until 601 was received successfully. Okay, and so that should explain some types of TCP connections that you'll see on your exam.